Okay, let's begin by doing some review over what we've learned so far about sine, cosine, tangent, and also special right triangles. So take a moment, maybe 5, 6 minutes to do these warm-up problems. Okay? All right, so let me go ahead and walk you through those now. So for all four of these, it looks like some of them are asking for a side, some of them are asking for an angle, some of them are 45, 45, 90s, others are 30, 60, 90s. So we have to really analyze what we're looking at first to know what we need to do. So for number one, it looks like they're looking for a missing side, and we don't have two of them. Like we can't use Pythagorean theorem here. So if that's the case and it's not a special right triangle, we're going to need to use sine, cosine, or tangent to write a ratio. So first you label. So from here, this is the opposite, the hypotenuse, and the adjacent. Make sure you know how to label those. Okay, we're going to do that a ton today. So now, adjacent and hypotenuse are the only ones we have info about. So I'm going to choose, remember we have SOHCAHTOA. You can also see them at the top of this page. Adjacent and hypotenuse belongs to cosine. So cosine of this angle is equal to adjacent, if I want to put that over here to help me, over hypotenuse. But that, of course, is just the same as 5 over x. Okay? To solve for x, we're going to want to get that x out of the denominator. So I'll multiply both sides by x. Like that. So if we wanted to show work, it'd look something like this. And then, of course, we want to solve for x. So cosine 54 is like a number, and you can't separate it at all, and it travels together. So you can't just divide both sides by 54 or divide by cosine. You divide by everything there. And the answer to this, and to the nearest tenth, is 8.5. Okay, next one. It doesn't label any of the angles for us, so we really would have no reason to believe it's a special right triangle. So we're just going to maybe set up a trig ratio again and just see what happens. So from A, this is the opposite. The hypotenuse is always across from the right angle, and this is the adjacent. So I know nothing about the hypotenuse, so I'm not going to use that. I'm going to use opposite adjacent, which is tangent. So I'll put A as the angle. And opposite over adjacent. All right. Okay, so a different scenario, right? The missing, so we normally call it x, but in this case it's a, but the missing quantity is now inside of the tangent. And in order to melt that tangent away, we want to use inverse functions. Because if you take the inverse tangent of tangent, you just get a. So we'll do it to both sides, and then we'll rely on our calculator to find this. And remember, this will be hit the second button and then hit the tangent button. And after you type that in, you're going to get 51 degrees. Also, make sure your calculator is in degrees. Forgot to mention, right? We're not going to use radians at all. So you can find that under mode. You can also find it under the, if you have one of the simpler ones, there's a button called DRG. You can change it there, or mode, something along those lines. All right. So now we have two special right triangles. So I'm going to remind myself of those rules. I'll write those down for you. You'll have these on the test. So let's see. So we have a 30, 60, 90, which means that we have to label the long leg, the short leg, and the hypotenuse. and we had these formulas that related them. It was the short leg times 2 is the hypotenuse, and the short leg times the square root of 3 is the long leg. Okay? So what do we know? I mean, we know the hypotenuse. So it makes sense to use this equation and solve for the short leg, right? Short leg is 10. And then now that we know the short leg, we can look at the other equation, because you're always going to utilize both equations because you have to find like both sides. So these two together will make this equation, 10 square root 3 equals long leg, which just happens to just be the exact answer we want. We don't have to solve for anything. Okay, so it's just about using the equations, manipulating them. You will have the equations. So these questions shouldn't be too challenging. All right, let's take a look at this one, which is a 45, 45, 90. The two equations for this guy is leg, and if you multiply the leg times the square root of 2, you get the hypotenuse. So this is leg, and those legs, again, are equal. Hypotenuse. So why not use this equation? Because we know the hypotenuse. Always use what you know. Like, use an equation that you know something about. Because if you don't, you're going to have like two unknowns and you won't be able to solve it at all. But this is pretty nice, right? So we just need to find a number that when you multiply it by the square root of 2, we get 14. And just like any equation, we want to divide to isolate. And this is the answer to both of the legs. But remember, we were really particular and we don't want square roots in the bottom, so we use this trick. And then we simplify if we can, right? Because 14 cut in half is 7. And that square root 2 is just multiplied on the top, so it just kind of hangs around there. So this kind of makes sense though, right? With those radical rules we've been doing. Isn't it true that this times square root 2 is 14? Have we found the right leg? Here and here. And it turns out, yeah, because the square root of 2 times the square root of 2 is just 2. All right. Glad we had that warm up. This is crucial to what we're going to be doing here today, especially these top two ones. Okay. So angles of elevation and depression. So an angle of elevation is created by looking up with respect to what we'll call a horizon line. Think of like the horizon at sunset, you know, that kind of horizon, a horizontal line. So if I'm hanging out here, the horizon line is always from the observer, the person who the problem's about, looking straight out. That's the horizon from eye level, or just from whatever the problem's telling you, right? And the angle of elevation is when you look up. So I'm going to call this the sight line. And you see maybe some birds up here or something. Okay. So an angle of elevation, maybe we'll call it X degrees, is turning up from the dotted line. Okay. So it's really important you're drawing this dotted line on your pictures. Okay. But yeah, angle of elevation means looking up. And then angle of depression, it means looking down. And then we also have to draw that horizon line. So now imagine I'm standing on the top of a cliff or a building, and my horizon line again is dotted line looking out, straight out, horizon, horizontal. But if I see like a garbage truck down here, right? This is my angle of depression. So I draw it, some people will just draw it like this. I don't think that's actually, it's correct, but drawing an arrow is showing you that you know that you're coming from the horizon line and looking down. And I did that same sort of arrow over here. It also helps you categorize elevation versus depression. Okay. Speaking of that, here's a question to help us practice that. Classify them as depression or elevation. So notice we have a bird here with a dotted line. The bird's looking over here, and this is the sight line of the bird. Put bird sight. Looking to the man in the balloon. Right? So, and that bird is looking down from their horizon line. So this would be an angle of depression. It's the bird's eye's point of view. Okay? For number 2, the sight line for the man in the balloon is looking at the top of the mountain. But, I'm sorry, that's the horizon line. The sight line is looking up at the bird. So from the horizon to the sight line, this would be an angle of elevation. So always start at the dotted line is what I'm trying to get across. So if the man is looking down, say there's a cow down here at the bottom, and if he's looking down from his horizon, that means that angle 3 would be an angle of depression. And this cow, who has a sight line that looks to the left, flat, might look up to see, the dotted line is the horizon line. I worry that I keep messing that up. And this is the sight line. Solid means sight line. So that cow is looking up, which means it must be an angle of elevation. Okay, so I can't stress it enough. We need to be drawing those horizon lines. Okay, let's solve some practice problems, and then you'll have the homework to also practice, and the answers to all of that is online too. All right. So it looks like we have 4 problems to do. So what I do with these is I always first try and draw a sketch after reading the problem. So a rabbit looks up, so that's key info that this is going to be angle of elevation, and sees a hawk perched in a tree at an angle of elevation of 40 degrees. If the tree is some amount tall, how far away is the hawk from the rabbit? Okay, so rabbit down here looks up. So the rabbit's horizon line is basically on the ground. The problem doesn't say that the rabbit is 6 inches tall or anything, so we're going to assume that that's kind of the ground level is the horizon. But the bird is looking up like this with 40 degrees at a bird that's in the tree up there. Okay? And the tree is 35, we'll label that. And they want to know how far away the hawk and the rabbit are. So we have 2 choices. Are we going to call this or this that length? It says nothing about the base of the tree. So I'm thinking this is going to be our missing value from the hawk to the rabbit. All right? Once you draw your picture, I like to draw a simplified one for me with just the numbers on it. So then it looks like a problem from 8.2. Yeah, just a simple right triangle trig question. So for every single one of these problems, you're going to end up picking sine, cosine, tangent, and solving an equation. And you'll probably get pretty sick of it. But this one is sine, right? Because this is opposite hypotenuse. So sine of the angle is 35 over x. And this looks like one of our warm-up problems we did. Number 1, where we had the x in the bottom. You see this right here? So I will go ahead and solve for x in the same way. Multiply both sides by x. And then divide both sides to isolate the x. And my calculator says this is going to be 54 feet rounded to the nearest foot. Okay? Good. All right. This one's a little bit more involved here. You suppose you stand 53 feet away from the base of a wind farm turbine. Your angle of elevation to the hub is 56.5 degrees. Your eye level is 5.5 feet above the ground. How tall is the turbine from the ground to its hub? All right. So there's some sort of wind turbine that's happening, which has those huge blades, right? But they keep talking about the hub. So I'm thinking the hub is going to be this blue center here. Okay. And it's telling us that we're on the ground. So we're here. And it tells us that this distance here, well, how about let's draw the sight line, which would come from our eyes. And that distance is 53 feet. And also, because this one we have to be a little careful because they give us information about how high we are off the ground. So, for example, this here is 5.5, and so it also is over here. So it's not like the rabbit where it's the horizon line was right on the ground. Now it's like lifted up a little bit. So we just have to make note of that in our picture and then adjust it to end. They also tell us an angle of elevation to the hub, which means that our sight line is looking at the hub. And we have that angle of elevation there. So the last part of this, I think, would be labeling what we want to find. And we want to know how tall the turbine is from the ground to the hub. So this is the question mark. But if I'm gonna have to solve a part of this right triangle to figure that out. So I want to call this part x. So before I use sine, cosine, tangent, I'm gonna redraw the picture with just the numbers that I care about currently, which is just that right triangle. And I want to solve for x, because if I have x, I have the answer, because I just have to add 5.5 to it. Okay, so this would be opposite, adjacent, looking across the way from the angle to get the opposite. So I'm thinking opposite over adjacent is tangent. So let me just write that over here. Opposite over adjacent is tangent of the angle. So opposite is x, adjacent is 53, and x is just one step away from being solved. We'll multiply both sides by 53. Okay, that is the answer. And for x, this is about 80. And then the height would be 80 plus 5.5, which, believe it or not, would actually round to 86, since we want the nearest foot, but 85.5 is okay. Okay, just pay attention to what we need to round to. All right, so that one was a little advanced, right? We had like this triangle, but it wasn't on the ground. You know, we had to elevate it up. So, but a good picture will always save you from this. All right, so now we have the Statue of Liberty, which has this little crown, and I'm just going to draw a stick figure for the whole body. And then it says that we are at the top of the Statue of Liberty. And it tells us that that is 250 feet above the ground. Okay. So looking out over the Hudson River, which must be a river in here. So remember, looking out or on the horizon would just be looking straight out. But it's mentioning an angle of depression. So it looks like there's a ship over here. So the Taurus is up there, but their sight line goes down from the horizon 18 degrees. Okay, so what's this distance then? Let's pretend like this ship is like maybe on the ground more, like down here. They don't tell us how like tall the ship is or anything. So what would this length be here? It's 250. It's kind of like a rectangle that we're forming here too. Keep that in mind too. They want to know the approximate distance from the Taurus to the ship. So that's a diagonal distance from the red guy on top to the ship. This would be the missing one there. And now our triangle has 3 labeled parts. So we can go ahead and use sine, cosine, or tangent. Not to spend too much time, we want to choose sine because sine is opposite over hypotenuse. And then we solve in 2 steps. We've done this just a few minutes ago and at the beginning. So I don't want to bore you with all the details, but 809, and we should put the units, feet, is that diagonal distance from the boat to the person. Okay? So there's an angle depression question for you. And finally, we have the airplane problem. So an airplane is 32,600 feet away from the landing strip where it begins its descent. Okay? So imagine there's definitely going to be an airplane up here. I'm not sure about the rest of the picture yet. So the airplane is 2,714 feet above sea level. So this up here, this table here that's printed on here, that'll be sea level. So this will be 2,715. And the airport is not at sea level. It's actually lifted up 1,007 feet. So the landing strip is here. And then there's the airport. What is the angle depression? Okay, now they want us to, we're solving for an angle. So a little bit different. We haven't labeled the 32,600 yet. And that's the distance from the airplane to the landing strip. It's a diagonal distance. The sight line, like this. And of course, the pilot looks out on the horizon like that, horizontal. So now we see the angle depression is coming from here. I think a common mistake would be to draw the angle of depression here. But that is not the case. That is not the case. Okay. So this is going to be, we'll call this X. And to finish the right triangle, I'm going to label that there. Because your angle depression has to be involved in your triangle that you're going to use. So for example, I would pick the one on top versus picking that triangle. Although you could do it that way, but this is a little bit more straightforward. Anyways, what is this? What's that? Or do we know this? It looks like we only have two pieces, the angle and the 32, 600. So we have these numbers. We haven't used them yet. And it turns out that this distance here and this distance, when we put them together on top of each other, it turns out, or maybe we could do this here, that if we take the red distance and subtract away the green distance, we get that height there. So, in other words, just subtract those two numbers and you'll get the height of that triangle. So big stick minus little stick equals 1707. Okay? I'm just going to keep this picture. So this is going to be opposite and hypotenuse, which reminds me of sine. So sine of x is opposite over hypotenuse. And what do you think? How do we solve for x? Because look at the problems we've done. This one, x was in the bottom. This one, x was in the top. And now we have one where x is inside of the sine. Okay? So if we want to free that x, we have to take the inverse function. So sine inverse of both sides will get us, the answer we want. Because this is now x. And that whole mess, if you type that in your calculator, you get 3 degrees. Okay, so this triangle is really skinny. All right, that's all I have. Try those homework problems and check the key.